बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलामु अलैकुम डियर स्टूडेंट्स। हम पढ़ रहे थे एमसीक्यूज़ ऑफ चैप्टर नंबर 1। तो चैप्टर नंबर 1 के एमसीक्यूज़ आप लोग निकाल लें। एमसीक्यूज़ इस तरह है कि आप लोग बुक निकालेंगे तो आपको ज़्यादा समझ आएगी। तो आप बुक निकालें और उसमें एमसीक्यूज़ पहले से पढ़ लें। पहले से पढ़ लेंगे तो इंशाल्लाह आपको ज़्यादा समझ आएगी। तो एमसीक्यू नंबर 8 को देखें। एमसीक्यू नंबर 8 है, मैं पढ़ लेता हूँ। एमसीक्यू नंबर 8 है 5.0 प्लस माइनस 4.0%। ओके, 5.0 प्लस माइनस 0.4% मल्टीप्लाइड बाय 3.0 प्लस माइनस 3.3%। 3.0 प्लस माइनस 3.3%। ओके, so it is 4.0%. okay, so we have to multiply these two measurements. Okay, 5.0 plus minus 4.0% and 3.0 plus minus 3.3%. We have to multiply these measurements. Okay, so using the rules of uncertainty, so multiply these numbers, these measured values with each other. So it will be 15.0. okay, yes, that is correct, 15.0. now look at the uncertainties here. There is the rule is multiplication here, so we have to add the percentage uncertainties. So it will be 7.3%. option B is the correct answer. Look at yes, option B is the correct answer. Look at MCQ number 9. MCQ number 9 is 2.0 plus minus 2.0% whole power cube. Okay, 2.0 plus minus 2.0% whole power cube. So it is power rule or quotient or exponent rule. Okay, so we have to use the rule for uncertainty in case of power rule. Okay, look at here. So taking the cube of this measured value, so the cube of this measured value is 8.0. This is the measured value. Okay, now use the power rule for this uncertainty. So the power rule is power multiplied by the percentage error. So it will be 8.0 plus minus 8.0%. okay, so multiply the percentage error with the power. So it will be 3 multiplied 2 is actually 6. okay, sorry, it is 6.0%. so option D is the correct answer. Option D is the correct answer. This is MCQ number 9. Now come towards MCQ number 10. MCQ number 10 said that the number of significant figure in the measurement of 0.007 7086 centimeter. Okay, we have to count the number of significant digits in this measurement. So look at here. These zeros are at the left side, so they are not significant. These zeros are not significant. Look at the middle one. This zero is significant. Why? Because it is in between the non-zero digits. So if it is in between the non-zero digit, it will be significant. Okay, look at these zeros. These zeros will be significant if there is a decimal point in the figure. So the right zeros will be significant if there is a decimal point. Okay, so number of significant figure is 1, 2, 3, 4, 5, 6. So there are 6 significant digits or significant figures. So the answer is option number C. C is the correct answer. Option C is the correct answer. Look at question number 11. Question number 11 said that how many significant figure does 1.362 plus 25.2? okay, 1.362 plus 25.2. okay, we have to tell that how many significant figure are there. Okay, so first we have to add these numbers. So look at here, 25.2 plus 1.362. okay, we have to add these numbers, so it will be 2 6 5 6 2. okay, the answer is 26.562. okay, look at here these measurements. Here there are three decimal digits, and here there is only one decimal digits, so the answer should have one decimal digit. The answer should have one decimal digit. okay, so the last digit is 6. If the last digit is 6 and 6 is greater than 5, so we have to add 1 in the second last digit and remove the last digit, so it will be 26.6 and remove the last digit. okay, so that is the correct answer. So there are three significant figure. Option B is the correct answer. Option B is the correct answer. This is MCQ number 11. Now come towards MCQ number 12. MCQ number 12 say that, look at your books. Compute the result to the correct significant figure of 1.513 plus 27.3. 1.513 meter plus 27.3. okay, 27.3 meter. okay, we have to find the answer with the correct significant figures. okay, so we have to add these numbers. So look at here, 27.3, so add these numbers. Look at here, so it will be 3 1 8 8 and 2. okay, the answer is 28.813. that is the answer. okay, so look at the decimal digits. Here we have 3 decimal digits, and here we have 1 decimal digit. So it means that the answer should consist of 1 decimal digit. The answer should consist of 1 decimal digit. So answer is correct up to here. It means that the last digit is 1. If the last digit is 1 and 1 is less than 5, if 1 is less than 5, so remove it. So the answer will be 28.8 meter. That is the correct answer. Option number B is the correct answer. Option B is the correct answer. okay. Now come towards MCQ number 13. MCQ number 13 says that if 7.635 and 4.18 are the two significant figures, their multiplication in digits will be, okay, so we have to multiply these numbers. 7.635 multiplied by 4.18. okay, we have to multiply these numbers, and we have to tell the answer of the correct significant figures. okay, so multiply it by calculator. So this one figure is 7.635 multiplied by 4.18. okay, so the answer is 31.9143. this is the answer. okay, 9143. yes, that is the answer. This answer is given by calculator. Now look at the significant figure. Here in this individual measurement we have 3 significant figure, and here in this individual measurement we have 4 significant figure. So it means that this is the least significant figure. So the answer should have 3 significant figure. So the answer should have 3 significant figure. So 1 is the last digit. If 1 is the last digit and 1 is less than 5, if 1 is less than 5, then remove it without any change. So the answer is 31.9 is the correct answer. 31.9 is the correct answer. So the answer should be option D is the correct answer, because it is more close to this answer. It is, option D is not accurate, but it is more close to this answer. So option D is the correct answer. 31.9. okay, now come towards MCQ number 14, the precision of the measurement 35,000 kilometer. Okay, 385,000 kilometers. So the precision of this measurement will be, so look at here, these three zeros, they are the three zeros. If they ask for the precision mean they ask for the least count. They ask for the least count. So look at here, these three zeros. So these three zeros say that the precision or the least count for this measurement is 1,000 kilometer. 1,000 kilometers is the least count. So that is option number C is the correct answer. Okay. Come towards MCQ number 15. M power 0, L power 0, T power 0 are the dimension of. Okay. M power 0, L power 0, T power 0 are the dimension of. Okay. Look at here. M power 0 mean 1, L power 0 mean 1, T power 0 mean 1. So it means it is dimensionless. So look at option A. Strain, yes, that is dimensionless. Refractive index, yes, that is dimensionless. Magnification, yes, that is dimensionless. So all of these is the correct answer. All of these is the correct answer. Option number D is the correct answer. So the last MCQ is MCQ number 16. Okay. The dimension of torque are, so we have to find out the dimension of torque. Okay. So torque has a unit of Newton meter. Okay. So what is Newton? Newton is equal to kilogram meter per second square. And meter is as it is. So multiply meter into meter. So it will be meter square. Okay, so what are the dimension of kilogram? That is mass, M square bracket. The dimension of meter is L square bracket, and the dimension of second is T square bracket. Okay, shift it 2 into the numerator, so it will be ML square T minus 2. These are the dimension of torque. So option number C is the correct answer. Option number C is the correct answer. So this is all about MCQs. Now come towards numericals. Now we are studying numerical problems of chapter number 1. Okay. तो सबसे पहले आप क्वेश्चंस रीड आउट कर लें, क्वेश्चन देख लें बुक में, बुक्स ओपन करें, सारे स्टूडेंट्स के पास बुक होनी चाहिए. विदाउट बुक आपको ज़्यादा समझ नहीं आएगी, तो इम्पोर्टेंट बात यह है कि आपके पास बुक होना चाहिए. तो बुक को देखें. अ सर्कुलर पिज़्ज़ा, look at question number 1. A circular pizza is cut into 3 equal parts. One piece of the pizza is taken out. Estimate the degrees measured of the single piece of pizza and convert the measure into radian. What is the radian measure of the angle of the remaining parts of pizza? Okay. So suppose we have a circular pizza. We have to divide this pizza into 3 equal parts. Okay. So we have to measure the angle made in the one piece and the remaining part of pieces in the pizza. Okay. So if we study this pizza is circular. If it is circular, so for the whole circle or for the whole cycle, it makes an angle of, for the whole cycle, it makes an angle of 360 degrees. That is the total angle in the cycle. Okay. In the cycle or in the whole round trip of this pizza. Okay. So for one part, divide this cycle by 3 on both sides. So it will be 120 degree. So 1/3 of the cycle will have 120 degree. It means that one piece will have a 120 degree angle and the other piece will have the 120 degree angle and the remaining part will have 120 degree. It means that each piece of the pizza will have 120 degree. Okay. So it means one piece of the pizza, that is 1/3 of the cycle, will have 120 degree. While the remaining pieces are 2 pieces, so multiplied by 2 on both sides. So the remaining pieces will have 240 degrees. Okay. The remaining piece will have 240 degrees. So one piece will have 120 degree and the remaining 2 pieces will have 240 degrees. That is the measurement of angle in degrees. Now they ask to convert this degree into radians. Okay, so we have to convert this degree into radians. Now we know that 1 degree is equal to 2 pi by 360 radians. We know that 1 degree is equal to, or we can write it as pi by 180 radians. So 1 degree is equal to pi by 180 radians. Okay, so for one piece of the pizza is 120 degrees. So write it here, 120 multiplied by pi by 180 radians. Okay, so zeros will be cancelled with the zeros, and it is cancelled by 6, so it will be 2 pi by 3 radians. So that is the angle for one piece. Okay, now we are converting this angle into radians for the two pieces. So look at here, so two pieces will have an angle of 240 degrees. So convert this degrees into radians, so it will be 240 multiplied by pi by 180 radians. Okay, so it will be 0 will be cancelled with the 0, and it will be 6, it will be 4 pi by 3 radians. Okay, that is the angle in radian for the two pieces. Okay, so that is the right answer. Now come towards MCQ numerical number 2. The length of the pendulum is 1.5 plus minus 0.01 meter, and the acceleration due to gravity is taken into account as 9.8 plus minus 0.1 meter per second square. Calculate the time period of the pendulum with uncertainty in it. Okay, so we have to calculate the time period with uncertainty. Okay, so look at here, this is numerical number 2, which is about the time period of the pendulum. This is numerical number 2. The length is given, the value of g is given. The length of the pendulum is 1.5 plus minus 0.1 meter. The g is 9.8 plus minus 0.1 meter per second square, and we have to find the time period of the pendulum. Okay, so remember, if these data consist of uncertainties, so the answer for the time period will be measured value plus minus total uncertainty. That is the answer for time period. Okay, this is the general answer. This is the basic method, you have to follow it. Inshallah, you will make no mistakes. Okay, for the answer we have to find out the measured value first. Okay, so first we have to find the measured value. How we can find the measured value? Remember, measured value can be found by the original formula of the time period. What is the original formula for the time period? That is 2 pi L over G under root. Okay, this is the original formula for the time period of the pendulum. So putting the value of length, measured value of length, the measured value of length is 1.5, the measured value of G is 9.8 under root. So it will be, calculator will give this answer as 2.4 seconds. That is the 2.458 seconds. 58 seconds. That is the answer for the time period. Okay, what is this value? This value is the measured value. This value is the measured value of the time period. Means half of the answer is clear. We have numerical number 2, that is the length of the pendulum is given, the value of g for the pendulum is given, and we have to calculate the time period of the pendulum with uncertainties. Okay, so the answer for the time period with uncertainty will be calculated value plus minus the total uncertainty. That is the answer for the time period of the pendulum. This is the general answer. Okay, so first we have to find the calculated value, then we have to find the total uncertainty, then putting the we will put these values here. This will be the answer. Okay, the question is how we can find the calculated value of the time period. The calculated value of the time period can be found by the original formula for the time period of the pendulum. The original formula for the time period of the pendulum is 2 pi L over G under root. Okay, so what is the measured value of the length? That is 1.5 meter. What is the measured value of G? That is 9.8 under root. So it will be 2.54 seconds. That is the calculated value of the time period. Okay. Now, for the correct significant figure, we say that there is only two significant figure. Here there is two significant figure. So we have to reduce this figure up to two significant figure. So it will be 2.5 second. Okay. So this is the correct significant figures. Okay. Now we have to find the total uncertainty for the time period. Remember, look at the original formula for the time period. Here L and G are in division. So we have to use the division rule. But remember, first priority is given to the power rule. First priority is given to the power. So what is the power of this length? The power of this length is 1/2. What is the power of G? That is 1/2. So the first priority is the power rule. So we will use power rule first for the length and G, then we will use division rule. Okay. So in the first step, we will find the percentage error in the length, then we will use power rule, then we will find the percentage error in G, then we will use power rule, then we can use the division rule. Okay. So first we have to find the percentage error in length. So the formula for the percentage error in length is least count by measured value multiplied by 100%. So the least count for the length is 0.1. The measured value is 1.5 multiplied by 100%. So the percentage error for the length will be 0.7%. 0.7% is the percentage error in the length. Okay. Now we have to use the power rule for the length because we know about the percentage error. Now we can use the power rule for the length. Okay. So what is the power rule? In case of uncertainties, we know that the power rule is power multiplied by the percentage error. Okay. What is the power? The power on the length is 1/2. And what is the percentage error? That is 0.7%. That is 0.7%. So if we use the power rule, so it will be 0.35%. It will be 0.35%. Okay. So this is the power rule. For the correct significant, we will say this error is 0.3%. Okay. Now we have to find the percentage error in G, then we will use power rule for G. Okay. Percentage error in G is, what is the formula for the percentage error? We know that. That is least count by measured value multiplied by 100%. Okay. So what is the least count for G? That is 0.1. What is the measured value for G? That is 9.8. Yes. 9.8 multiplied by 100%. Okay. So what is the value given by the calculator? That is 1%. Okay. It is actually 1.01%, but for the correct significant figure, up to the correct significant figure, it will be 1%. This value is the percentage error in G. Okay. Now, if we know the percentage error in G, then we can use the power rule for G. So what is the power rule? The power rule for G is power multiplied by the percentage error. So power for the G is 1/2. And the percentage error is 1%. So it will be 0.5%. Okay. So if we know the error in length and the error in G, then we can use the division rule. So for the total uncertainty, use the division rule. The division rule is summation of percentage errors. What is meant by summation? Summation means percentage error in one quantity plus percentage error in another quantity. Okay. Summation means we have to add the percentage error in length and percentage error in G. So what is the percentage error in length? That is 0.3%. Percentage error in G, that is 0.5%. So it will be 0.8%. That is the total uncertainty. So putting these values in the answer, the general answer for the time period is equal to calculated value plus minus the total uncertainty. So the calculated value is 2.5 plus minus total uncertainty is 0.8 second. That is the correct answer for the time period with uncertainties. Okay. Now come towards numerical number 3. Okay dear students, now come towards numerical number 3. Numerical number 3 is look at your books. Determine the area of the rectangular sheet with length 1.50 plus minus 0.02 meter and the width is 0.20 plus minus 0.01 meter. Calculated the area with the uncertainty. Okay, so we have to find the area with the uncertainty. Okay, so the answer, look at the general answer for the area. The general answer for the area is calculated value plus minus total uncertainty. This is the general answer for the area. Okay, so first we have to find the calculated value for the area, then we will find the total uncertainty, then we will put these values here. This will be the answer for area. Okay, the question is how to find the calculated value for area. The answer is by the original formula of the area. What is the original formula? Length cross width. Okay, so what is the measured value of length? We know that is given 1.50 multiplied by 0.20. okay, so the answer for the calculated area is 0.3 meter square. 0.3 meter square. That is the calculated value of the area. So half of the answer is known. Now we have to calculate the total uncertainty for area. Okay, so what is the rule for total uncertainty in case of multiplication? Here these two are in multiplication, so we have to use the multiplication rule. So the multiplication rule is percentage relative error in length plus percentage relative error in width. Okay, so first we have to find the percentage error in length, then we have to find the percentage error in width, then we will add them, so we will get total uncertainty for the area. So the percentage relative error in length, its formula is absolute uncertainty divided by measured value multiplied by 100%. So what is the absolute uncertainty for the length? That is 0.02 meter and the measured value is 1.5 multiplied by 100%. Okay, so that is what is the percentage error of length? That is 1.33%. okay, 1.33%. so up to correct significant figure it is 1%. okay, that is the percentage error in length. Now we have to find the percentage error in width. So it will be percentage error in width. So what is the formula for the percentage error in width? Percentage error in width, that is absolute uncertainty divided by measured value multiplied by 100%. Multiplied by 100%. Okay. So what is the absolute uncertainty for the width? That is 0.01. Measured value is 0.20 multiplied by 100%. Okay. So what is the answer given by the calculator? That is 5%. Okay, 5% is the percentage error in width. Okay, now we know the percentage error in length, that is 1%. We know the percentage error in width, that is 5%. So putting the values in the total uncertainty, so the total uncertainty will be 1% plus 5%. So it will be 6% is the total uncertainty. 6% is the total uncertainty. So putting these values in the general answer, the general answer for the area is calculated value plus minus total uncertainty. So the calculated value for the area is 0.3 meter square plus minus 6%. That is the answer for area. Okay, now take another step for the in this calculation. So look at this 6%. If we want to find the percentage error in this area, so we can easily calculate this. So look at here, 0.3 has error of 6%. So we have to find out what is the 6% of 0.3. So percentage mean divided by 100. So it will be 0.2. Okay, 0.02. It is 0.02. So the answer for the area will be 0.3 meter square plus minus 0.02 meter square. Okay, that will be the correct answer for the area with uncertainty. Okay, this is question number 3. Now come towards question number 4. Question number 4 is 246.24 plus, this is part A, 246.24 plus 238.278 plus 98.3 plus 98.3. Okay, so we have to add these numbers up to correct significant figures. So look at the numbers. So 246.24 plus 238.278, you can add them by calculator, and 98.3, so it is 8 1 it is 3 5 and it is 8, 6 and 8 is 14 plus 8 is 22, 2 is here, 6 and 3 is 9 and 18, and 1 is here, that is 5. So the answer is 582.818. that is the answer. Okay, yes, that is the answer. Now look at the decimal digits. Here we have 2 decimal digits, and here we have 3 decimal digits, and here we have 1 decimal digit. So the least decimal digit is 1 decimal digit. So the answer should have 1 decimal digit. So it means that 1 is less than 5. So remove it directly without any change. So it will be 582.8. That is the correct answer for this measurement. Okay, now come towards its part B. Part B. So look at part B. 1.4 multiplied by, look at part B, 1.4 multiplied by 2.639 plus 117.25. Okay, so we will multiply first or add first. You know that first we have to multiply these numbers. So look at this. If we multiply these numbers, so we will get if we multiply these 1.4 and 2.6 by calculator, so you will get 3.69 946 plus 117.25 as it is. Okay, so if we multiply these numbers by calculator, so we will get this, and this number is as it is. Now we have to add these two numbers. So it will be 117.25 3.946. okay, So 6, 9, 11. Okay, so it is 8 plus 3, 11. So it is 2, 1. Okay, so the answer is 121.196. Okay. Now use the rule for addition. So look at here. Here we have 3 decimal digits, and here we have 2 decimal digits. So the answer should contain 2 decimal digits. So it means that answer is correct up to here. So it means that 6 is the last digit. If 6 is the last digit, it means it is greater than 5. So if it is greater than 5, then add 1 in the second last digit. So it will be 121.20. That is the correct answer for this figure. Okay, that is the correct answer. Now come towards part C. Part C for this MCQs is 2.66 multiplied by 10 power 4 minus 1.03 into 10 power 3. Okay, so we have to subtract these numbers. Okay, first convert this scientific notation into standard form. So it will be 2.66 into 10 power 4. So it means that we have to shift the points for the 4 times. So it will be 26600. Okay, 1 2 3 4. Okay, so this is the standard form of this figure. Because we shift the decimal digit for the 4 times. 1 2 3 4. Yes, that is the standard form. Now convert this scientific notation into standard form as well. So that is 1.03 into 10 power 3. Okay, so its standard form is we have to shift the point for the 3 times. So it will be 1030. 1 2 3. Yes, that is the standard form. Now we can subtract them. So the first figure is 2.6600. Another one is 1030. Okay, so now we are subtracting this figure. So it will be 0. Now we are subtracting. Okay, there is a subtraction between them. Look at here, that is subtraction. Okay, so it will be 7. It will be 5. It will be 5 plus 2. Okay, this is the answer for subtraction. Now convert this figure into scientific notation. So 1 2 3 4. So it is 2.5570 into 10 power 4. That is the answer for subtraction. Now look at the rules for significant figure. Here we have 2 decimal digits, and here we have 2 decimal digits in the given question. So if there are 2 decimal digits, and here there are also 2 decimal digits, so the answer should have 2 decimal digits. So it means that 7 is the last digit, and 7 is greater than 5. If 7 is greater than 5, so add 1 in the second last digit. So it will be 2.56 into 10 power 4. That is the right answer for this subtraction. Okay, so that is the correct answer for this subtraction. It is 2.56 into 10 power 4. Okay, now come towards numerical part D. So what is part D? Look at your books. What is part D? Okay, part D is 112 multiplied by 0.456 divided by 3.2 into 120. 3.2 into 120. Okay, so we have to multiply it and divide it by calculator. So use the calculator here. If you use the calculator, so we will get we will get 0.134. This is the answer given by the calculator. This is the answer given by the calculator. Now look at the number of significant figure. Here we have 3 significant figure, here we have 3 significant figure, here we have 2 significant figure, and here we have 2 significant figure. So it means that the minimum significant figure are 2, so the answer should consist of 2 significant figure. So it means that 4 is the last digit. If 4 is the last digit, 4 is less than 5, so remove it directly without any change, so it will be 0.13. That is the correct answer for part D. Okay. Now come towards part E, that is 168.99 multiplied by 9. Okay, first calculate them by calculator. So we will have 1520.91. okay, this answer is given by the calculator. So first convert this figure into scientific notation. So it will be 1 2 3, so it will be 1.52091 into 10 power 3. Okay, now look at here. Here we have 5 significant figure, and here we have 1 significant figure. So there are 5 significant figure, and here there is 1 significant figure. So the answer should consist of 1 significant figure. So it means that the last digit is 5. If the last digit is 5 and there are some certain digits after 5, so you have to add 1 in the second last digit, so it will be 2. So if you add 1 in the second last digit, it will be 2, and remove the last digit, so it will be 2 into 10 power 3. So that is 1 significant figure in the answer. That is the correct. Okay. Now the last option is option F. The last option is option F. Option F say that 1023.8.5489. Okay. 1023 plus 8.5489. Okay, we have to add these numbers. Okay, let them add. 1023 8.5489. okay, so what will be the answer? Look, 9 8 4 5 plus 0.1310. that is the answer given by the calculator. This answer is given by the calculator. Okay, look here. Look at here. Here there is 4 decimal digits, and here there is no decimal digit. So the minimum decimal digit is 0. The minimum decimal digit is 0, means no decimal digit. So the answer should have no decimal digit. So it means that the last digit is 5. If the last digit is 5 and there are some certain digit after 5, so add 1 in the second last digit. So the answer will be 1032. That is the correct answer, and remove the last digits. So that is all about numerical number 4. Now come towards numerical number 5. So first I have to erase the board. You have to read numerical number 5. First read it out. Numerical number 5. Okay. Calculate the answer up to appropriate significant digits. The ratio of the mass of the proton to the mass of the electron. Okay. So first we have to find out the ratio of the mass of electron to the mass of proton. Okay. First we have to know the mass of proton to the mass of electron. Sorry. Mass of proton to the mass of electron. What is the mass of proton? 1.67 into 10 power minus 27 kg. What is the mass of electron? 9.1096 into 10 power minus 31 kg. Okay. So we have to calculate it. So look at here. Divide them by calculator. So we will get 0.1834 into 10 power 4. While the kilogram will be cancelled out. Okay. Kilogram will be cancelled out. So look at here. Sorry, it is 3. Now look at here. There are 3 significant digits and there are 5 significant figures. So it means that the minimum significant digit are 3. So the answer should have 3 significant figures. So it means that this 3 is the last digit, which is less than 5. If it is less than 5, then remove it directly without any change. So its answer is 1.183 into 10 power 4, or we can write as 1.83 into 10 power 3. Both the answers are correct. So its answer is 1.83 in 10 power 3. Okay. Now come towards part B. This was part A of question number 5. Now come towards part B. The ratio of the charge on electron to the mass of electron is, okay, the ratio of the charge on electron to mass of electron. So the charge on electron is 1.6 in 10 power minus 19 coulomb. The mass of electron is 9.1096 into 10 power minus 31 kilogram. Okay, now we have to find the ratio. Now find out this answer by calculator. So it will be 0.1756 into 10 power 12 coulomb per kilogram. Okay, now look at the significant digits. Here we have 2 significant digits and here we have 5 significant digits. So it means that the minimum significant digits are 2. So it means that the answer is correct up to here. So it means that 5 is the last digit. If 5 is the last digit and there are some certain digit after 5, then add 1 in the second last digit, whether it is even or odd. Okay, so the answer is 0.18 into 10 power 12, or we can write it as 1.8 into 10 power 11 coulomb per kilogram. That is the correct answer for the significant figure. Okay. Now come towards numerical number 6. Numerical number 6 said that come towards numerical number 6. There are 2 parts of numerical number 6. In the first part, look at the question. Find the dimension of Planck's constant. Okay, first we have to find the dimension of Planck's constant, then we have to find the dimension of gravitational constant. Okay, in the first part we have to find the dimension of Planck's constant. In the second part we have to find the dimension of gravitational constant. Okay, so what is the formula for the Einstein, for the Planck's? What is the formula of the Planck's? That is E is equal to hf. So h will be equal to E by f. H will be equal to E by f. Okay, so what is the unit for energy? That is joule. What is the unit for frequency? That is per second. Okay, so the unit is joule second. What is joule? Joule is equal to Newton meter. Second is as it is. Second is as it is. What is Newton? Newton is equal to kilogram meter per second square. And meter is as it is. Second is as it is. Okay, so second will be cancelled out. So it will be kilogram meter square per second. Okay, so the dimension of kilogram is m square bracket, dimension of meter is l square bracket, and dimension of second is t square bracket, and shifted the t in the numerator, so its power will be negative. So it is ml square t minus 1, or the dimension of Planck's constant. Okay, now we have to find the dimension of g. Okay, so first tell me, what is the unit of g? The unit of g is Newton meter square per kg square. That is the unit for g. Okay, so what is Newton? Newton is equal to kilogram meter per second square, and meter square as it is, kilogram square as it is. Okay, so kilogram cancelled out, so it will be meter cube divided by kilogram into second square. So dimension of meter is L cube, dimension of kilogram is m square bracket, and it is t square bracket. Okay, shift the mass and time in the numerator, so its power will be negative. So m minus 1, t minus 2, L cube, that are the dimension of g, gravitational constant. Okay, now come towards the last numerical, that is numerical number 7. Numerical number 7 is the last numerical of this chapter. Okay, show that kinetic energy is equal to E half mv square and potential energy is equal to mgh are dimensionally correct. Okay, So here this question has two parts. Kinetic energy is equal to half mv square and potential energy is equal to mgh. So we have to prove whether these equations are dimensionally correct or not. Okay, so first let us take part A. Part A is kinetic energy is equal to half mv square. Okay, now first taking left hand side. Left hand side is kinetic energy. Kinetic energy, what is the unit? That is joule. What is joule? Newton meter. What is Newton? Newton is equal to kilogram meter per second square, and meter is as it is, so it will be kilogram meter square per second square. So these dimensions will be m l square t minus 2. These are the dimension of the left hand side. Okay, now taking right hand side. Right hand side is half mv square. Okay, what is the unit of mass? That is kilogram. What is the unit of speed? That is meter per second whole square. While 1 over 2 is dimensionless, unitless. These are the constants, so these are dimensionless. Okay, so apply the square on both, so it will be meter square per second square, meter square per second square. So convert it into dimensions, so it will be ml square t minus 2. So look at the dimension of left hand side and right hand side are equal. So if the dimensions are same, it means that the equation is dimensionally correct. So it is proved that the equation is dimensionally correct. Now come towards part B. Part B is potential energy is equal to mgh. That is part B. Now first taking left hand side. Left hand side is potential energy. The unit of potential energy is joule. What is the unit? That is joule. Okay, joule is the unit. What is joule? Joule is equal to Newton meter. Joule is equal to Newton meter. Okay, so what is Newton? Newton is equal to kilogram meter per second square, and meter is as it is. Okay, now multiply meter with the meter, so it will be kilogram meter square per second square. Now convert these units into the dimensions. Okay, so it will be ml square t minus 2. These are the dimension of left hand side. Now now taking right hand side. Right hand side is mgh. Okay, what is the unit of mass? That is kilogram. What is the unit of acceleration? Meter per second square. What is the unit of h? That is meter. Okay, so multiply meter with the meter, so it will be kilogram meter square per second square. So convert it into meter, so it will be mass m square bracket l square bracket and t minus 2. So write it in the one bracket, so it will be m l square t minus 2. So look at here, the dimension of left hand side and dimension of right hand side are equal. If the dimension of left hand side and right hand side are equal, so it is proved that potential energy is equal to mj is dimensionally correct. So this is all about numerical problems of this chapter. So I hope you will understand it completely. Till then, Allah Hafiz. Now we have another topic of chapter number 1, that is error. Okay, so what is the definition of error? The error can be defined as it is the difference between the actual value and the measured value, or we can define it in this way: error is a doubt about the results of any measurement. Okay, so error is a doubt about any measurement. Or look at the first definition, it is the difference between actual value and measured value. Okay, so write it as actual value minus measured value. Okay, for example, the actual length of a rod is 10 centimeter. A student measured it and he found it is as 9.7 centimeter. Now we want to find the error in this measurement. Okay, so the error is defined as actual value minus measured value. So actual value is 10 centimeter and the measured value is 9.7 centimeter. So the error will be 0.3 centimeter. This is the error in the actual value in the measurement. This is the error in the measurement. Okay, so error is actually the difference between actual value and measured value. Okay, now we are classifying this error into different types. So we are discussing the classification of errors. The first error is systematic error. The first error is systematic error. Another error is a random error. So there are two types of errors. The first one is systematic error and the other is random error. Okay. So first we are discussing the systematic error. Okay. So remember, systematic error can be defined as the error which is fixed. The error which is fixed, which is not changing. It is fixed. Remember, the error that tends to be in one direction. The error that tends to be in one direction. So it is also called unidirectional error. It is called unidirectional error. Remember, it may be positive or negative. At the same time, it will be positive or negative. Okay, so it is unidirectional error. Now we are discussing the types of systematic error. We are discussing the types of systematic error. Okay. The first type is instrumental error. The first type is instrumental error. Okay. Instrumental error. Okay. Instrumental error arises from the error due to the imperfect design or calibrations of the measurement instruments in the sensitivity of the instruments. Okay, suppose if we want to measure a galvanometer and we want to calibrate it, and if we made it the poor calibrations of the ammeter or galvanometer, so poor calibrations is the type of systematic error, because this poor calibration is the error which exists in the device, which exists in the instruments. So this poor calibration is called instrumental error. Okay. Now first if I discuss the example of instrumental error, that is the zero error. Zero error is the example of instrumental error. We know that zero error may be positive zero error, may be negative zero error. So zero error may be positive or may be negative. So zero error exists in the device. So this is called instrumental error. The question is how we can minimize this instrumental error. So remember, systematic error can be minimized by improving experimental techniques and selecting better instruments, quality apparatus. So we can minimize instrumental error. If we don't use the quality apparatus, then the systematic error will be fixed and will remain there. It cannot be removed. Okay. Another type of systematic error is personal error. So personal error is the type of systematic error. Okay. How we can define it? The error due to the carelessness of or improper knowledge of the measuring instruments or incorrect reading of the scale by an experimenter is called personal error. If a person assume wrong calibrations in ammeter or galvanometer, so that is called personal error or systematic error. Okay. So if a person takes the value of G is 9.8, which is the actual value of G, but somewhere the value of g may be 7.8 meter per second square. So if in real the value of g is here at one place, and we assume the value of g is 9.81, which is wrong, so that type of error is called parcel error, and parcel error is a type of systematic error. So this error arises due to the carelessness of the person, or this error arises due to the improper knowledge of the person. So these are the two types of parcel errors. Okay. Suppose if I talk about the response time in the measuring of time period of the pendulum. So if I made some mistakes in the response time, then this type of error is a parcel error. So this is also called systematic error. Okay. Now come towards the random error. How we can define the random error? So random error can, look at the random error. This is another type of error, random error. Okay. So I'm reading the random error as the error which occurs irregular and hence a random with respect to sign and size is called random error. Okay. So if we have scattered readings or measurements, so that type of error is called a random error. Means this error is not fixed. It is changing continuously. If it is changing continuously, so this type of error is called random error. These errors can be arise due to the unpredictable fluctuations in the environmental conditions. So this error may be arise due to the unpredictable conditions of the environment, because we know that the environment is changing unpredictably. So due to these conditions, for example, if we talk about the temperature of the environment, if we talk about the pressure of the environment, if we talk about the humidity of the environment, etc. So these are the environmental factors due to which this error maybe arises. Okay. The example is, if we want to find the speed of sound in summer, that will found is 340 meter per second, and if you want to find the speed of sound in the winter, that will be found is 330 meter per second. So this change in the speed of sound, these errors in the speed of sound is due to the environmental factors. So this is called a random error. Okay. So how we can control the random error? Maintaining strict and controllable laboratory conditions. Repeat the experiment again and again, and then take its average, so we can minimize the random error. So this is all about errors. So error is the difference between actual and measured value, and there are two types of error: systematic error and random error. Okay. While the systematic error has further two types: instrumental error and the parcel errors. And the last one is random error. Inshallah, I hope you will understand it. Okay, Allah Hafiz.